50% of you are watching this on a mobile phone, 40% are using a computer, 6% on a tablet, and finally 4% on a TV. I want you to ignore the percentages, but focus on the fact that all the viewers are using a device with a lithium-ion battery. Okay, maybe not the TV, but the remote still counts. The lithium-ion cell is a massive part of modern-day technology, and we are running out of lithium. A quick Google search shows us this. An electrochemical cell is a device capable of either generating electrical energy from chemical reactions or using electrical energy to cause chemical reactions. We need to go over the basics. Lithium atoms form positive ions with a +1 charge when they ionize and release one negatively charged electron each. This diagram shows a lithium-ion cell, and a battery is just a bunch of these connected in series to produce a higher voltage. There are 2 electrodes at either end, both in contact with a solution called an electrolyte, which is a liquid that allows charge to pass through it. There is also a separator in the center to only allow lithium ions to pass through. Around the outside of the cell, there is a conductor wire bridging the anode and the cathode. So at the anode, lithium is stored and it ionizes, releasing electrons into the negative end of the conductor wire. The electrons flow to the cathode, creating the electric current that we can use in our devices. However, the left is more negatively charged due to the buildup of electrons. To balance the charges, the lithium ions move through the electrolyte to the cathode. Over time, all the lithium ions move to the cathode, and there will be no more electrons released at the anode. Recharging simply uses a power supply to drive the reaction in the opposite direction, moving the electrons back to the anode. Consequently, the lithium ions move back to balance the charges again, and the battery is now recharged. You don't have this luxury with non-rechargeable batteries, as they don't use a reversible reaction. As a result, most of these end up in landfill. Many of the reactants in the cells are harmful to the environment, and some are even carcinogenic. For many of us, the first thing we touch in the morning is the cold casing of our mobile phones, and inside, you probably guessed, is a lithium-ion battery. Yet, we still haven't discussed the elephant in the room: electric vehicles. Designed to be the savior of our planet by eliminating carbon emissions, electric vehicles seem like a brilliant solution to the carbon crisis. So it's no surprise that many countries are banning fossil fuels in the early 2030s and switching to electrical cars, which are of course powered by lithium-ion batteries. But wait, the average electric vehicle requires 10 kilograms of the stuff. This, coupled with the fact that 1 ton of lithium requires 5.3 tons of lithium ore and 2.3 million liters of water, makes lithium a not-so-friendly prospect for the future of our planet. The demand for lithium is already quite strong, with a price increase of 738% in the past year, as shown by these graphs. And once countries start meeting that deadline for electric vehicle production, the pressure will skyrocket. So will we really be saved by the cell? Probably not. Lithium extraction comes with its own set of ethical issues. It is undeniable that using lithium-ion cells produces less carbon, but the immense amounts of energy required to extract the lithium in the first place comes from fossil fuel power plants anyway. So is it really as good for the planet as we make it out to be?